Hello everyone. Today we will discuss about the metabolism of the ketone bodies. In this topic we have various subtopics, that is the ketogenesis, ketolysis and various other clinical aspects. But in this video we will particularly talk about the ketogenesis. Now first of all, you may know that the carbohydrate is very important for the beta oxidation of the fatty acid, or we can say the breakdown of the fatty acid. If carbohydrate are not present, the beta oxidation of fatty acid doesn't occur because the fat is mainly burned under the fire of the carbohydrate. So if you remember, we talk about the beta oxidation of fatty acid, and in that at the end acetyl-CoA is formed. Now this acetyl-CoA will actually enter into the TCA cycle for further breakdown or for further ATP formation. But in the absence of the carbohydrate or the lack of carbohydrate, as in starvation and diabetes mellitus, in these two cases we either not eat or eat very less amount of carbohydrate. So what happened in this, the acetyl-CoA will not enter into the TCA cycle, but rather will go into the ketone bodies formation pathway, or we can say ketogenesis pathway. Now ketogenesis mainly over here, as you can see, we have mainly two type of ketone bodies: primary ketone body and the secondary ketone body. Primary ketone body are the acetoacetate. Remember, acetoacetate are the primary ketone bodies, while the secondary ketone bodies are the beta hydroxybutyrate, and one more is there, that is the acetone. So acetoacetate, beta hydroxybutyrate and the acetone. Now they are mainly synthesized exclusively in the liver mitochondria. Just remember, they are mainly synthesized in the liver mitochondria. Now we have mainly in the ketogenesis we have mainly 5 steps. So we'll talk about each individual step in detail. Now first of all, step 1 is the condensation. Now I told you that from the beta oxidation pathway, the acetyl-CoA will actually enter into the ketogenesis pathway. So as you can see, 2 acetyl-CoA will condense together in the with the help of in the presence of acetyl-CoA synthase. I told you before also in every video that in order to remember the enzyme name, just remember the name of the either product or the substrate and the reaction they do. Okay, over here acetyl-CoA synthase as the product name, acetyl-CoA synthase is formed. Okay, and over here COAS, what is this? This is the coenzyme A. This is the coenzyme A over here, and it is mainly formed, and the acetyl-CoA is mainly formed. So condensation, 2 acetyl-CoA will be joined together, and the COS, I told you before, what is this? It is the coenzyme A having pantothenic acid, beta mercaptoethanolamine, and one amino acid, and one more is there, that ADP is present. Okay, over here. So it will be removed, and because of this it will form acetoacetyl-CoA. Now in the second step, there is production of the HMG-COA. This is the beta hydroxy beta methyl glutarate CoA or coenzyme A, HMG-CoA. Now this acetoacetyl-CoA will actually, in the presence of one molecule of acetyl-CoA will get from the beta oxidation fatty acid product. So this along with the acetyl-CoA, in the presence of HMG-CoA synthase, will form HMG-CoA. Okay, now in the third step what happens is, now remember the mitochondrial HMG-CoA over here. Just remember the mitochondrial HMG-CoA synthase, this enzyme is mainly used in the ketogenesis pathway, while the cytosolic fraction means in the liver mitochondria, whatever HMG-CoA synthesis is present, it will be used in this process, ketogenesis. But in the cytosolic place of the liver, this HMG-CoA synthesis present will be used in the cholesterol synthesis pathway, right? So now next is the step 3, that means the lyse. Lyse, that means of course cleavage or the breakdown. Now over here the beta hydroxy beta methyl glutarate CoA or HMG-CoA, in the presence of HMG-CoA lyse will form acetoacetate. I told you before, it is that acetoacetate. It is the primary ketone bodies, and remember secondary ketone bodies are the acetone and the beta hydroxybutyrate, BHB, you can remember by that, beta hydroxybutyrate, and the acetone. Well, this is the primary ketone body. It will form one primary ketone body and one acetyl-CoA. Now this acetyl-CoA can be used further in the step 2. In this step also it can be used. So it will form acetoacetate, which will further go in the 4th step. Now step 4 is the reduction process. Now over here, as you can see, the acetoacetate, which was the primary ketone body, will convert into beta hydroxybutyrate, which is the secondary ketone body. Okay, primary ketone body form a secondary ketone body by the dehydrogenase process. Now over here, the acetoacetate undergo reduction process. Okay, and of course NAD will convert into NADH2. But remember that the ratio between the acetoacetate and the beta hydroxybutyrate is actually decided by the cellular NAD and NADH2 formation. So we can just assume that if the acetoacetate amount is more, so of course the release of hydrogen is not done. So of course NAD proportion is more. So if acetoacetate is more, so NAD proportion is more. If the beta hydroxybutyrate proportion is more, so NADH2 or NADH presence is more. Okay, because the ratio actually depends, this ratio acetoacetate and the beta hydroxybutyrate ratio depends on NAD and NADH presence or the ratio, right? So if this is more, of course NAD is more, and if this is more, so NADH is more, or we can do vice versa also. Now the last fifth step is the spontaneous decarboxylation. What happens over here is, okay, you can see the acetoacetate is a primary ketone body. Okay, so it will undergo non-enzymatic and spontaneous decarboxylation reaction and will form the acetone. And again, if you remember, acetone is again a secondary ketone body, just as beta hydroxybutyrate. So we can say that from the primary ketone body, two secondary ketone bodies are mainly formed, one by reduction and one by decarboxylation. So let's go through it once again. As you can see, the 2-acetyl-CoA molecule condense to form in the presence of the acetoacetyl-CoA synthase will form the acetoacetyl-CoA. Now this acetoacetyl-CoA combined with one molecule of acetyl-CoA in the presence of HMG-CoA synthase will form the beta-hydroxy-beta-methyl glutarate-CoA or HMG-CoA. Now this HMG-CoA will undergo LYSIS or the breakdown of this HMG-CoA in the presence of HMG-CoA LYSIS and will form two substances, that means the acetoacetate, which is a primary ketone body, and the acetyl-CoA, which is actually again used, it can be again used back to the step 2. And this acetoacetate in the step 4 undergo reduction process and will form the beta hydroxybutyrate, which is actually a secondary ketone body. And the ratio of the acetoacetate and the beta hydroxybutyrate can be get by the help of the NAD and NADH2. NAD and NADH ratio. If the NAD is more, acetoacetate is more. If the NADH is more, so beta hydroxybutyrate is more. Now another pathway is in the step 5, the acetoacetate actually undergo decarboxylation process or the non-enzymatic and spontaneous decarboxylation process, and it will form another secondary ketone body, which is actually known as the acetone. So these are the 5 easy steps of the ketogenesis, which mainly occurs in the mitochondria of the liver. We'll talk about the ketolysis, ketosis and the clinical aspects of the ketone bodies in our next further videos. Hope you understood it well. Thank you so much.